Okay, this lesson is going to be over stretch and shrink of linear functions. So let's start out by graphing f of x. Okay, if you've seen my other videos, we've just kind of been plugging in x's, and we should have, so let's say when x is 0, then f of x is also 0 because they're equal. And here's my x and f of x axes. Okay, f of x is just the same thing as y, essentially. It's saying a function in terms of x. If we had a function f of x equals 3x or something, it's going to be a function in terms of x. If we had a function that said f of d is equal to 3d, that would, notice the variables are the same. So that's kind of what that means. Okay, sorry to go off on that tangent. So here's a point at 0, 0. When x is 1, f of x is also 1. When it's negative 1, f of x is also negative 1. And so we should end up getting a function, and I could just keep going with points. We should end up getting a function, and I'm doing my best trying to make a straight line, straight as I possibly can. Okay, and we should end up getting a function that looks like that. Okay, let's try it. Let's graph the next one. We have 4 this time. So f of x equals 2x. So when x is 0, 2 times 0 is 0. When x is 1, 2 times 1 is 2. That's f of x. And negative 1, 2 times negative 1 is negative 2. Okay, and we should end up getting these points. So we have at 0 at the origin, at 1, 2, and at negative 1, negative 2. And we should end up getting, if I just kept making points, we should end up getting a function kind of looks like this. Okay, and so notice that when I multiplied by a coefficient of 2, my height ended up doubling. So I'd have, here's the height, and if I do it 2 times, I end up getting to this graph, right? From the x-axis to here, if I double that, I end up getting a point on here. So really, I'm just doubling that, or we would say a vertical stretch. Okay, so let's see here. Let's try the next one. F of x is equal to 1/2 x. And so if I ended up getting, let's see, when x is 0, I should have 1/2 times 0 is just 0. When x is 1, 1/2 times 1 is 1/2. When x is negative 1, negative 1 times 1, negative 1 times 1/2 is negative 1/2. Right? And you don't have to use these x values. You could use any of them. I just use these because they're easy. They're pretty simple. So we'd have a point at 0, 0, at 1, negative 1, or excuse 1, 1/2, and to get 1/2, I just go halfway between 0 and 1 in the y direction, and negative 1, negative 1/2. And so we should end up getting a function that looks like this. I'm going to try and draw it as straight as I possibly can. And if you notice, the height from the x-axis to my parent function, right? This is this black graph right here, this black line is the parent function. And we talked about that in the vertical translation video. But if you notice that from the x-axis to the parent function, that height, and the x-axis to the new function, 1/2 x, is actually, this height is 1/2 this height. Okay, if we look at it over here, we have this height is 1/2, or is twice as much as this height, or in other words, this height is 1/2 this height. If we look at where the origin is, that doesn't have it has a height of 0 from the x-axis. So half of 0 is just 0. So what we would say is that when we multiplied by 1/2, or like a fraction that's between 0 and 1, we ended up doing a vertical shrink. You could also say it was a horizontal stretch, like you're stretching it sort of like a rubber band. Okay. So we have that. So last one, and I'll do this one in green. Okay, is we have f of x equals to negative x. And so, again, let's plug in values. When x is 0, f of x is negative 0, which is just 0. Let's see, when x is 1, then we'd have f of x is equal to negative 1. When x is negative 1, then we would have a negative of a negative 1, which is equal to a negative times a negative is a positive, right? Just like if you were saying in words, I am not going to the store. Well, that means you are going to the store. Okay, so let's plot those points. So we'd have at 0, 0, we have 1, negative 1, and negative 1, 1, negative 1, positive 1. And so if I kept going, then I should end up getting a line that looks like this. I'm trying to make it as straight as possible. Okay? And so if you notice, let's talk about how it relates to the parent function. We have the distance from the x-axis to the parent function, and if I pick up that distance and move it, notice it's the same distance to our new function f of x equals negative x. If I look over here, here's the distance from the black function, the parent function, to the x-axis, and if I take that distance, check it out from here, x-axis to the green function, it's the same. So what we would say is that when a is negative, when we make our parent function into a negative x, then we would end up reflecting over the x-axis. Okay, and you can, if you see the distance here is also the same as here, you could actually say we reflect over the y-axis as well. But typically we kind of go with the x-axis reflection. Okay, so, and to reflect means like it's a mirror image. So if we would have, we take this function and it's just a mirror of, this function is just a mirror of the parent function. So what we would say is we basically have like 3 conditions, and we're all basing it off of this function right here. F of x is equal to ax. So 1, when a is greater than 0, excuse me, not greater than 0, greater than, when a is greater than 1, which means, I'm just going to talk about positive values right now, so 1.5, 2, 2.5, 3.25, 5, 7, 10.5, 10, and 3/8. Anything bigger than 1, we would end up, just like this one, doing a vertical stretch, making a vertical stretch. So vertical stretch. Okay. Number 2, when a is less than 1, and I'm talking about just positive values, so that would mean a being less than 1 would also mean a is greater than 0. So greater than 0 and less than 1. We would have, let me clean this up a little bit so it's easier to see. Okay. We would have a vertical shrink. Vertical shrink, and so we would take this function, right, and it shrunk, the height shrunk, and since it was 1/2 x, it shrunk by, it cut the height in half. If it was 1/3, it would take this height and cut it into 3 parts and only take one of those parts. Okay, and so it would be smaller and smaller and smaller. Okay, so that's the second one. The third incident that we just talked about today is when a is negative, which means a is less than 1. Okay, we notice we have a is greater than 1 up here, a is less than 1 here. It undergoes a reflection. Okay, and it was specifically, in this case, it was over the x-axis. Okay, and so, right, we just ended up doing this and this, right? The distances were the same. So it went as a reflection. If I ended up having it, if it was like, if I changed this function right here to instead of negative x, if I had it as negative 2x, then it would end up reflecting, and this height would double. So I would get a function that looks like, I'll do this one in purple. This reflects and the height would double. I want to make sure I get this right. And so I would get something, this should also go through the origin. Get something like that if I ended up doing negative 2x for f of x. Okay?